for the sake of this class. Then after talking about those terms, we look at atomic model. Atomic model. Then after that, the quantum numbers. So we look at the quantum numbers in summary. Then the rules that guide electronic configuration. And that should be all. So technically, let me even do it in a very simple manner. There's what we call the structure of the atom. Inside the structure, you have what we call the nucleus. The nucleus is the center of the atom, and everybody here should know that. Now, at the nucleus, we have some particles. Those particles we have in the nucleus, they are your neutrons and protons. So neutrons and protons are found in the nucleus. Then there is a surrounding around that nucleus. That surrounding is usually called the shell. It is also called the energy level. It is also called orbits. So we have the shell, we have the energy level, we have the orbit. This shell can be of different numbers. We have the K, the L, the M, and so on. So we call it the K, L, M, N shells. Then around these shells or orbits is where you have a guy that carries a negative charge, and that guy is called electron. So that is what we are looking at. So this is the structure of the atom for basic diagram. So the question they can ask you is the location of the electron, the location of protons and neutrons, the nucleus. I already told you, please. These are still, I already told you, please. These are still basics of chemistry. And naturally, you should have known all these things I'm saying. But if you do not know, that's why I'm revising it again. And don't expect me to give you notes because we don't have all day. We don't have time. We have only done matter last week. We did matter last week. Imagine we do atomic structure this week. Then next week we do periodicity. Then in another week we do chemical bonding. Then that means 1 month, 4 topics. In another month, 4 more topics. We will not do anything in chemistry. So all of you that are still complaining, if you know you want to learn, and you really want to understand, you need to find time. Our Saturday might be included for classes. So you that your parents called me and they said that I want to kill you, that Monday to Friday is enough. It's actually enough for me, and we have time to rest. But now that you can still see us around, it's better you even choke our neck that we should teach you and not go anywhere. Because even if it's 4 topics to finish till the end of the syllabus, till the end of the exam, it is not our problem. It is still your problem. You are the one that will go and face it in exam hall. And people that will pass will still what? Will still pass. So that's what they always say. But it is very important that when we are sacrificing our own time for you, you should understand that. And don't see it as if we are stressing you. Because we know there is no time, we need extra time. You two, you did not join last year. Some of you just joined this week, today. And you are part of the people that will complain that want a man stress in your brain. It's okay, we clap for you. So, A represents what we call the atomic mass. A is called atomic mass, and Z is called atomic number. And that atomic number is the same as what we call the number of protons. So what is the difference between atomic mass and number of protons? Your atomic mass is usually given as number of protons plus number of neutrons. You can represent it as mass number is equal to number of protons plus number of neutrons. This is a formula you will need. That means that the number of protons plus the number of neutrons you have in this place represents what we call the mass number or the atomic mass. So moving on from there, let me take a quick example. This is an atom. This atom is called aluminium. The atomic mass is 27 and the atomic number is 13. So if I ask you that what is the atomic number, it is 13. What is the number of protons? It is 13. What is the mass number? 27. But if I now say what is the number of neutrons, then you have to calculate that. That is 14. If you do not know how I got that, you pay 20,000. You can say, please, I do not understand. So the mass number is 27. The number of protons is 13. Then the number of neutrons is what you are looking for. So number of neutrons is going to be 14. Is that taken? As we move on, you still see that there is a difference in what I'm talking about. So that is the introduction to atomic structure. Now, atom was believed to be the smallest part of every element or everything we have in the universe. But we realize that atom can be broken down into 3 parts, and those are called the subatomic particles. And those are the things we have talked about: the protons, the electrons, and the neutrons. Simply write them. So, quickly, I will use a table. Can I rub the board? Yes. You can determine all these ones yourself. Can I rub the board? No. Yeah, please, let's be fast. All these are basics, they are still basics, and they are not things we should waste time on. Please open your brain. You are the one that resumed in January, and 3 months is actually not enough for us. If we want to explain things properly, to pick it one by one, it's not enough. But those that have been around since last year, I know they tried as much as possible to cover the syllabus around December. So now it should be more like a revision for them. All of us want to study medicine, nursing. We want to score 350. You'll be resuming 1 or 2 months to jam. Let's score 350. And you did all these things for 6 years in your secondary school. I was seeing some GS1 questions yesterday when I was in church. I saw some GS1 questions. We were asking them all the things we are teaching you now. We are asking them sublimation, examples of substances that will sublime. GS1. Can I rub the board? Yes. You cannot see.
Okay, you cannot see.
I don't know why you can see from here. There is no way you cannot see. You will just adjust at some point. If you don't draw see, you give on to shake gas okay and you will see that. So let's move on. Now, talking about the subatomic particles, I will just use a table for that. So your atom is made up of 3 particles. Pen. So those 3 particles are protons. We are going to use a table. Electrons and neutrons. So these are called the subatomic particles. So what are the properties of these subatomic particles? The first property is the charge. Proton is positively charged. Electron is what?
Negatively charged.
Fatima, the class back to swear proposita. You should get out of the class. You are saying it, go outside.
Ella?
Neutrons are what? Neutral. Then we have their location. Where do we have new protons? Electron. In the shell, Abby. Then this one is also found in the nucleus. Please, this means it is neutral. We all should know that. We have the mass. The mass is in atomic mass units, AMU. That mass in atomic mass units for proton. Proton is 1. While electron is 1/1840, that of proton. Proton is 1/1840, the mass of proton. So, which means that if you know the mass of proton, this value multiplied by that mass is what will give you electron, the mass of electron. Electron is very, very small compared to proton. Like imagine whatever proton is, divide it by 1/840. That shows the mass of electron. So electron is, which means that proton, if I say mass of electron is equal to 1/1840, that means I'm saying the mass of proton over 1/840. That means the mass of proton is going to be mass of electron times 1/840. So that means mass of proton is 1/840 times greater than mass of electron. Do you get that? That's what that part is just trying to tell us, that proton is very, very heavy. So imagine you and I now, I am 1/840 bigger than you. That means you multiply my own mass with 1/840. That shows how huge proton is. Mass of neutron too in atomic mass units 1. Then they can also represent their masses in kilogram. Mass in kilogram. Mass of proton in kilogram is 7 times 10 raised per minus. That's 27 in kilogram. That's for proton. For electron, it is 9.11 times 10 raised per minus 31 kilogram. While for neutron, it is 1.68 times 10 raised per minus 27 kilogram. So those are the masses. But for the values of the charge, you need to note something. Proton and electron, their charge is 1.6 times 10 raised per minus 19 coulomb. That's the charge of the values of the charge. There are some calculations you might be doing later that you will need all of these values. So you have to know them offhand. So these are the properties of the subatomic particles. Remember, neutron has no charge, so you can't give it a value. So now, can we move on? So let's quickly look at some terms we use when talking about the structure of the atom. Are you ready? Yes. I don't know how you can sit there and you say you cannot see the board. Even people sitting directly behind them, they can still manage to see. I think on Shelo Magic, if you want to learn, you will learn. We are doing physics. The farther you are, the better you see. There will be no obstruction. So the obstacle that is very far from you cannot stop you. The obstacle that is close to you will stop you. But you are that far and you are still saying you cannot see. Tí wo bá sí, so alájà tó wà lẹ́gbẹ̀ẹ́ náà ríran. Tí wọ́n bá tẹ̀ wá rápá kan tó náà rápá kan, ẹ máa sọ́ lójijì. But you are not ready to learn. That's the problem. So I know it's really blocking you through the we're asking to be there, but you're only complaining of the ability. So can we move on? Oh yeah, let's be fast. I already told you why we are summarizing these things. This is the best you can even get. You cannot start writing notes. If I start teaching you atomic structure properly, it will take us up to 1 month. This topic alone. It will take us up to 1 month because I will analyze all those Bohr model, hydrogen spectrum, everything very well. It will take us 1 month. But something that you might not even see one question in the exam, you are now going to spend the whole of 1 year on it. So please be wise. And everything we are doing is for your own sake. Can I rub the board? Just be getting used to these things little by little. So quickly, what are the terms you hear when you are talking about atoms? Number one, you have heard about the term atom itself, Abby. The smallest part of anything is your atom. The smallest part of anything you have in the universe, that's your atom. Element is the smallest part of a substance that can take part in a chemical reaction and that cannot be further splitted into any smaller bits. That's your element. The washer will pass WAEC. They will not ask you the definition in exam more. So there are some things, even if you want to know the definition and you want to form a note, you can write that after the class. I explain it in the first class, so don't let us waste time on it. Another thing you need to know is atomic number. So what is atomic number? Atomic number is simply defined as the number of protons in the nucleus. That is atomic number. So number of protons in the nucleus. That is atomic number. Then mass number. What is mass number? That is the total number of protons plus the neutrons in the nucleus. That is mass number. That means number of protons plus the neutrons in the nucleus. That's mass number. All these are normal terms you can be hearing. We have talked about it. At your level, it's not stories that you need, it's understanding. The next thing is nucleus. Nucleus. Nucleus is talking about, it's a collective name. Collective names for protons and neutrons. That is what we call nucleus. So if I say protons and neutrons, I can just say nucleus instead of having to say protons and neutrons. So the moment I say nucleus, you already know I'm talking about protons and neutrons. Are you there? Number 6, aeons. So let me quickly explain aeons in a summary. When you're talking about aeon, an aeon is an atom. When an atom loses electron or gains electron, then it becomes what? An aeon. Then it becomes an aeon. Is that taken? So now, when atom loses electron, what type of aeon do they form? Positive or negative? Positive. So when atom loses electron, they form positive aeons. When they gain electron, they form negative aeons. And these negative aeons are usually called anions. While positive aeons are called what? Anions. All these are basic knowledge. So that is the thing, without wasting much time. Can we move on?
Yes.
So let me give you an example to that. Let's say this is sodium. The atomic number for sodium is 11. The electronic configuration is 2,8,1. When sodium loses one electron, it will form Na+, then 2,8 plus 1 electron. So it has lost 1 electron, then it's carrying plus. So the number of plus indicates the number of electron loss or gain. So if I write A of 3 plus, what does that mean? It has lost 3 electrons. If I write O2 minus, it means it has gained 2 electrons. I hope you are following.
Yes.
What is our basic knowledge? Please. The notes. If an atom is neutral, the number of protons will be equal to the atomic number, and it will be equal to the number of electrons. E.g., aluminium, 17, 27. This atom, since it's not carrying plus or negative, it means it is what? Neutral. Is that taken? Now, what is the atomic number for this guy? 17. Abi? What is the number of protons? 17. What's the number of electrons? So, the moment an atom is neutral, number of protons will be the same as atomic number and will be the same as number of electrons. Is that taken? Let's look at this guy. Can you determine the number of protons here? That's 6, Abi. Atomic number is also what? Number of electrons is what? Because it is neutral. So, secondly, if it is charged, that means it is already an ion. So, if it is charged or is an ion already, all these things, even if you don't understand clearly, that's why you have to form groups that you can read together, so that at the end of the day it becomes so clear. We should not waste time on this, please. There are a lot of things you should waste time on. Those are your chemical kinetics. And so if you see people repeating some classes, it's not because they have not tried. They have been reading, they have been doing their best. Things are not just working out. And you cannot be spelling things for someone. The problem we can have now is most of you that are just learning. That you are just learning. And you also want to score 350. And it's not magical. Just keep trying your best. Keep trying your best. What we are doing now, try your best to get it. Try your best. And make friends with those that can put you through. If I give you notes for this night, it does not mean you will score 350. I come and waste time. But just try your best to be wise. So, when an atom is charged, the number of protons remains the same. It will not change. And it will still be equal to the atomic number, but will not be equal to the number of electrons. So when an atom loses or gains electron, the only thing affected is what? Electron. It is not the protons. So which means that, look at this guy again. Let's now check it here. Let's say I have Al3 plus. What does that mean? It has lost 3 electrons. Abi? Say that the atomic number is 13, mass number is 27. So look at this now. They now say what is the atomic number? What's going to be the atomic number? I told you, even when it is charged, it does not affect the atomic number. It remains what it is. These are parts you now need to note that they can ask you in exam. I'll show you something quickly. What will be the number of protons? It does not change. But what will be the number of electrons now? 10. Because it has lost 3 out of 13. So it will now be what? 10. Do you get this difference?
Yes.
Let's take another example. Ca2 plus 20 and 40. Oh yeah, quickly. Determine the atomic number, the mass number, the number of neutrons, number of protons, and the number of electrons. Oh yeah, quickly. These are the things you need now. So all those initial stories might not be needed. And whatever they ask you here, they will put it out. They will say when an atom gains electron, it becomes what? It becomes negatively charged, and so on. When you start practicing questions, you see. And what will expose you the more is the number of questions you're able to practice. It's not about these stories. So what is the atomic number? What's the mass number? 40. What's the number of neutrons? 20. You know how they got that, Abby. What's the number of protons? 20. What's the number of electrons? 18. Do you get that now? Yes. So let's look at this again quickly, because I know these are aspects they can ask you questions. O2 minus. In O2 minus, 8 and 16. What's the atomic number for this guy? 8. What's the number of neutrons? 8. What's the mass number? 16. What's the number of protons? 8. 8. What's the number of electrons? 10. So to those of you that said 6, you remember, minus means it has what? Gain. Do you get that? It has gained 2 electrons, so you will add it to the 8. That makes 10. Do you see the difference now? Another way they can now make it so technical for you is that, look at this, A2S. Then I underline this S and tell you that what is the number of electrons. I'm trying to make it look technical, but there's nothing there. A2S, for this S, what do you think is the charge carried by this S? 2 minus. So that means, you know, this, if I break this down, this is H plus S2 minus. So 2 will be here. If I break A2S into the A, that's what it will give me. And I underline S, that should tell me the number of electrons. That means it has gained 2. And normally, sulfur is 16, Abby. Yes. So if I say what is the number of electrons, that means my answer will be 18. Do you get that? Yes. All these are basic things that you just need to have understanding. I'm actually not too fast. I'm not just giving you notes. That's the difference. So can we move on? Yes. Please, do we understand ions now? Yes. So when atoms become charged, then it becomes an ion. So, can I rub the body? Yes. Thank you. So, the next time you want to talk about is, let me say, isotopes. So you have some atoms that are different, but they have the same number of neutrons. Iso means same. Nu means neutrons. So when you have atoms with the same number of neutrons, they are said to be isotopes. Is that taken? Yeah. Let me look for example. Let's say I have oxygen 16 and 8, carbon 14 and 6. Let me just quickly take this. What's the number of neutrons here? 8. What's the number of neutrons here? 14 minus 6? 6. So you can see that this isotope carbon and this, they have the same number of neutrons, so they are said to be isotopes. So when you calculate the number of neutrons for all of the atoms, and you see that the number of neutrons are the same, then you say they are what? Isotopes. Is that taken? I hope you are following. Isobars. Isobars, from the word bar, they have the same mass number. The one that used to be at the top is mass number. So isobars means atoms or nuclides of the same mass number, but different atoms. So e.g., I have potassium 40, 19 and calcium 40, 20. Those are two different atoms, but their mass number are what? The same. So when their mass number are the same, you say they are what? Isobars. Not so difficult. Next one. Isoelectronics. The word isoelectronics means they have the same number of electrons from the word. Same electrons. That is what isoelectronics means. So they are nuclides or atoms with the same, or ions with the same number of electrons. Can we move on? Yes. So e.g., Ne, the atomic number for this guy is 10. Mg2 plus, the atomic number for this guy is 12. Al3 plus, the atomic number is 13. Practice is what will make you perfect. It's not this class. Which other one? Let's say O2 minus. The atomic number is 8. So look at all of these guys, the 4 of them. The first one, Ne, that's neon. What do you think is the number of electrons? 10. Number of electrons is 10. Magnesium, number of electrons is what? 10. Because of these two, it means it has lost 2. So the number of electrons is also 10. How about this? 10. How about this? 10. Do you understand that now? You have done the calculation before. So this one, the number of electrons is 10. The number of electrons for this is 10. So when you calculate it, and you see that all of their electrons are the same, then these guys are said to be isoelectronic, meaning that they have the same number of electrons. Do you understand that?
Yes, sir.
Thank God there are a lot of tools you can use to learn these days. So the next one is isotopes. Isotopes. And from the word isotopes, it means same protons. So they are nuclides of the same elements, meaning that they have the same number of protons, but they have different mass number. E.g., H11, H21, H31. They can ask you questions on these guys. The first one is called protium. Protium. And protium lacks neutron. Lacks neutron. So they can ask you, it's something you can calculate yourself. If you say 1 minus 1, that's 0. So that means there's no neutron. Is that taken? But the 3 of them are isotopes. How are they isotopes? They have same atomic number, but different mass number. But you see that their number of neutrons also vary. This one is called deuterium. Deuterium, also known as heavy hydrogen. Heavy hydrogen. And the number of neutrons here is 1. Abi? So you can see that their number of neutrons will be different. This one we have 0 neutron. This one has 1 neutron. But this one is called tritium. So this one has 2, number of neutrons here is 2. And this one is radioactive. So those are the important things you need to know about them. So tritium is radioactive and it has 2 neutrons. So you can see that their numbers of neutrons are different, and that's why they have different mass number. So when you are solving questions, so they can give you different reasons. Just think about it. It's not so hard. When you start solving questions, you will know. Can we move on?
Yes.
Now, another example of isotopes. Carbon 6 and carbon 14. They are also isotopes. So they have different mass number due to difference in their number of neutrons. So when you want to do some calculations on isotopes, when we are doing calculations in chemistry, they will tell you that take the relative atomic mass to be this. In giving you the relative atomic mass, they have calculated a whole lot of things together. I could have given you 1 or 2 or 3, but I don't know which one is present. So I can do the average. So when I do the average of these guys, it can be used as 1 in doing my calculations. So if you are doing, they ask you to calculate relative atomic mass for a particular isotope. The formula is this. That is the sum of the masses multiplied by the abundances. Now, these are their masses. I can call this M1, I can call this M2, I can call this M3, depending on their number, you sum everything. Then, the abundances means that báwo ló ṣe pọ̀ tó. How many of these guys do I have? Let's say I have 20% of these guys present. I have 30% of this guy present. Then this should not be up to 50, but just for hypothetical example. because it's radioactive, so it should not be much. So now, all these are called the abundances, and it must sum up to 100. So if they ask me to calculate the relative atomic mass for this guy now, I'm going to say that the sum of the masses, that's M1, let me represent the abundance with A1. So this can be A2, A3. So masses times the abundance, 1 times A1 plus sum plus M2 times A2 plus 3 times A3 all over A1, that's sum of the abundances, A1 plus A2 plus A3. So this will give me the relative atomic mass, and that is the formula. So it continues depending on the number of isotopes you have. So you can put these values there to check for that, or we'll solve more questions on that. So before I stop, let's say I have my M1. So you can see that A1 plus A2 plus A3, when I solve them up, that means A1 plus A2 plus A3 can give me 100%. And if they are not more than 2, it will just be that one might be around. I have chlorine 35, atomic number 17, with abundance of 25%. And I have chlorine 37, atomic number 17, with abundance of 75%. So if they ask me to calculate this relative atomic mass, what will I do? Then I can say my relative atomic mass is going to be M1 multiplied by A1 plus, because there are no more than 2, M2 multiplied by A2 all over A1 plus A2. That will be my formula. And what's my M1? 35, A1 25, M2 37, A2 75. Then I will add 25 plus 75, that makes 100. That will give me the answer. So you see questions on this when you start solving. So, but note something. Note these two formulas that can help you. RAM can be equal to M1, A1 plus M2, A2, and so on. And A1 plus A2 can be equal to 1 in fractions. Then A2 can be equal to 1 minus, A2 can be equal to 1 minus A1. If you make A2 the subject of the formula, then from here now, I can now say that RAM is going to be M1, A1 plus M2 into 1 minus A1. So this formula will be useful when they ask you to calculate their abundances. If they say calculate abundances here, you don't know this, you don't know this, it's going to be a problem. But you have reduced it to just say 1. So when they give you this, they give you this, they give you this, and they say find A1, you can easily solve for it. If they say find A2, then you put whatever you get as A1, you bring it here, then you get A2. So we are going to take examples when there is time, for those that will understand. So you can quickly have your break now. Then by exactly 1, we should be back to class. So this is 12:39. Abby?
Yes.
So by 1, we should be back to class. So go and get